All right, guys, so this is sections 3 and 4, and they pretty much go hand in hand with 1 and 2. So we're going to go through these pretty quick. Push pause when you need to. All right, first, looking at the pictures that you have with the marks that are made, is there enough information to prove that M is parallel to N? So if this is line M and this is line N, do we have enough? And if we do, which theorem? So is it going to be, your choices are alternate exterior, alternate interior, corresponding, same side interior, or same side exterior. All right, so looking at the marks in the picture, all right, so first of all, I see that this angle right here is congruent to this angle right here. Well, if I look at that slice of pie situation, these two are in the same area or the same slice of pie. So yes, because corresponding angles are congruent. So now I can say M is parallel to N because corresponding angles are congruent. Corresponding angles are congruent. So that's all you're doing. You're just, last time I said, hey, if your lines are parallel, then these are corresponding angles and they're congruent. Now I'm saying, hey, these angles are congruent. So now the angles or the sides are parallel. So it's this is kind of like the converse. All right, looking at this next one here. These two angles are congruent, absolutely, because they're vertical, okay? But remember, you don't need, if I were to take, so just to kind of give you an idea and make it super visual. Okay, if I were to cover up this, you still see those two angles. So that means I don't need this line down here for these to be congruent. So therefore, no, these are not vertical angles, do not determine if lines are parallel. And I'm going to type it because I can type it a lot neater. So no, vertical angles do not determine if lines are parallel. Oops, if lines are parallel. All right, so vertical angles do not determine if lines are parallel. All right, next. So now I have a lot of lines going on. And again, these are vertical, okay? If I were to take this box right here and I covered up that, and then also trying to make this here. So if I covered up both of those, I can still see those angles. So again, this is no for the exact same reason. Vertical angles do not determine if lines are parallel. End of story. All right. Now, I know this is a little hard to read. I apologize. Find the value of x that makes m and n parallel. So now we're just going to assume that they're parallel so we can solve for x. And if it works, then great. So what we're going to do here is, first of all, these are in a corresponding position. All right. So I am going to say that 8x plus 55 is equal to 95. So I'm going to subtract 55 from both sides. That gives me 40. And I still have 8x left. Then I'm going to divide both sides by 8. So 8 times 5 will give me 40. So lines M and N are parallel when the marked corresponding angles are congruent. And I'm just going to put the congruent symbol there. So when these are marked congruent, then these two lines will be parallel. So lines M and N are parallel when x equals 5. So you're doing the same thing we did last time. It's no different. Okay, this time, these two are in, first of all, this is my transversal, and they're alternating, and they're outside. So lines M and N are parallel when the marked alternate exterior angles are congruent. So lines M and N are parallel when x is equal to. So we know we've got 200 minus 1x equals 130. So I'm going to subtract 200 from both sides. That gives me negative 1x equals negative 70. So x is 70. If I divide both sides by negative 1, when x is 70 is when it's going to work. All right. Next, find the measure of the angles. All right, so now these are same side because this is my transversal here. So these are same side interior angles. So remember what I said about same side interior angles? Because of all the S's, same side interior angles are supplementary. So I'm going to add these two things together. So x plus 2x equals 180. 3x equals 180. X is 60. So this time, this angle here is 60. This is 2 times 60, so this one is 120. And there you go. It says find the measure of the angles. That angle is 60. That angle is 120. They do add up to 180, so I know I did it right. All right. Now, we have a proof. Okay, and that's kind of the whole point of this. And you've been doing proofs. We've just not been writing them down. So given that angle 4 is congruent to angle 5, so that is my given information. And I want to prove that G is parallel to H. So I know that angle 1, so angle 1 is congruent to angle 4 because they are vertical angles. And vertical angles are always congruent. The 4's here are going to cancel out, so that means angle 1 is congruent to angle 5, and that's the transitive property. So if 1 and 5 are also congruent, then G and H are parallel because of corresponding angles. So corresponding angles are congruent. So basically, take what's given, what we know. They'll never tell you this part because they're going to expect that you know vertical angles. So remember, draw an X, you get vertical angles. All right. There's also a transitive property of parallel lines, meaning if P is parallel to Q, so if P is parallel to Q, and Q is parallel to R, so now Q is parallel to R, then P is parallel to R. Okay, same thing. It works the same exact way, all right? So now it says in the diagram to the right, P is parallel to Q, and Q is parallel to R. So all three of them are parallel. So I have three parallel lines. Find the measure of angle 8. Well, if I were to just pretend for just a second that this one wasn't here and just had these two, then that means that this angle 115 and angle 8, they're on the same side of the transversal and they're outside the parallel lines. So these are same side exterior. Okay, so I could say that angle 8 is same side exterior. So therefore they're supplementary. So angle 8 plus 115 equals 180. So subtract 115, and angle 8 is 65. So we also know that this one's 115, and these two are a linear pair, so that makes this one 65 also. So you could look at it 2 or 3 different ways. Either way, I like to go for same side exterior. All right, last part. All right, so proving that theorems are about perpendicular lines. So it says if two lines intersect to form a linear pair. So I have two lines, they're making a linear pair. And they're a linear pair of congruent angles, then that means the lines are perpendicular. So if angle 1 is congruent to angle 2, then G is perpendicular to H. In a plane, if a transversal is perpendicular, so if a transversal is perpendicular to one of two parallel lines, then it's automatically perpendicular to the other because those two angles are corresponding. In a plane, if two lines are perpendicular to a transversal, then they are going to be parallel. Same thing, you have corresponding. All right, so it says to determine which lines are parallel. So I see that this is 90 degrees, but they didn't tell me anything about this one. So there are no parallel lines. So, no lines are parallel because Q is not perpendicular to S. Okay, so no lines are parallel, so nothing is parallel because it did not tell me these two were perpendicular. You can't assume it if they don't tell you. All right, number 11. I know that P, this line right here, I know that this line is parallel to this line because these two angles are 90. So P is parallel to Q because P is perpendicular to R and Q is perpendicular to R. And this one, let's see, we are going to prove that, so if this is 90 and this is 90, then M is parallel to N because they are both, because M is perpendicular to K and N is perpendicular to K. So there's that. Now is J and K. So now I can go up here, I'm going to use a different color so that they don't mix together. So now I can say that J is parallel to K because M is perpendicular to J and N is perpendicular to J. So anytime things are perpendicular like this, you're going to have parallel lines. Okay. All right. So these are short and sweet. We're going to extend on this when I see you guys next time. So have a great day and I will see you guys later. Bye.